Hello, everybody. Okay, so streaming the Hangout through OBS was problematic. I don't know why. I was doing it wrong, probably user error. So I'm going to be inviting the same two guests we had and whoever else would like to join. Let me get this going here. And I gotta figure out how to invite Multi, so hopefully he's in the stream already. Let me pop over there. All right. Need MultiT0mt0m's channel or something. Can somebody, right? Like I am Rick, send me a link to MultiT0mt0m's channel. Need MultiT0mt0m's channel. I'll try and find it myself, but I should have clicked on it before I moved over. Every time I search for his, it doesn't pop up. I don't know why. Right. Oh, there it is. Yes. Okay, so the heck? I was send a message. Okay. Jared, come back. I am Rick. How did you invite Multi?
Hello.
Hello, hey Tony.
How you doing?
Doing good, man. Trying to figure out how. Merry Christmas, yeah. Trying to figure out how to invite MultiT0mt0m.
Oh, you want to argue with Multi, don't you?
I just want some entertainment.
Yeah. How about work right now? I saw you jumped on, so I wanted to at least jump on real quick. I still got to do side work. I came out to smoke a cigarette. That's how addicted I am to Hangouts.
No worries. Thanks for joining.
Yeah.
Yeah.
It's good to see you doing stuff, man.
Thanks, man.
So you saw how Alex was tearing into Multi earlier, huh?
I was doing Christmas stuff earlier. I heard something had happened, but I hadn't actually been able to go back and watch it. Doing family stuff earlier.
Yeah.
But
I just wanted to jump on real quick. You'll be on hopefully for a little bit. I got to do my side work, then I'll jump back on later. I just want to say, in case I didn't see everyone, Merry Christmas to everyone.
All right. Appreciate that, man.
Yep.
Thanks for stopping by.
Yep.
Okay, somebody tell me how to invite MultiT0mt0m here. I can't figure out how to send a daggone message on YouTube. I thought it was in the About section. Oh, there it is. Okay, here we go. All right, let's see if MultiT0mt0m comes back. There he is. MultiT0mt0m, I just sent you a link in your YouTube messages. And this one says error again? I'll just put it in the description. How about that? And snipers. I'm sure we'll have to deal with snipers, but oh well. All right, I have added a link to the description for anybody that wants to join. For some reason, linking it in the live chat is causing an error right now. I'm not sure what that's about. Oh, it's happening in the other one too. So, should be there now. And anybody that wants to join can, so please do. Just a little bit of end of Christmas entertainment for us going on here. And we have Spock on a Cock and MultiT0mt0m.
Hey.
All right. Hey, Adam. Jared, Multi. Welcome all. And Merry Christmas. Happy holidays.
Yeah, against my religion, to be honest.
Okay. Well, whatever. Whatever.
Because.
Well, it's just a cultural holiday. I mean, it's all it is. It's a time for everybody to get together and hang out.
Yeah, love and let live. That's what I say. Love and let live.
There you go.
What I say.
All right, so yeah, go ahead, Multi. You got the floor, man. Let's see.
No, I mean, you know, you guys, why are you so against flat Earth? You know, people are becoming awakened by this new realization that the ball Earth is bullshit.
Yeah.
Right.
You see, flat earthers have this tendency to use words in the opposite meaning. This is not an awakening. This is a enlightening. It's like the reverse of the knowledge enlightenment. You know, you're going the opposite direction. This isn't it's not a debate. And the Earth is a globe. We know it is. The evidence is easy to observe yourself. You know, at first you might not know where to look or how to see it. Took me a while to even kind of work out what I was looking for, but once I realized that you could see it in the perspective of telephoto, then it really is easy for anyone else to do. You just grab P900 and you know, go to the 15th floor of the Marriott, and there you
go. No, I mean, a lot of the heliocentric model doesn't make sense to a lot of people, you know, millions of people, to be honest.
Yeah, well, neither does quantum physics, but it's still a real thing. Jared, you got some.
I will say that going on. My letter. All right, hang on.
Just check my mic. Am I sounding okay?
Yeah, you sound good, Adam.
Good, thank you.
You know, the heliocentric model is built on, I wouldn't say a lie, you know, but it's built on errors. You know, if you really research the history of how the heliocentric model came to being, you'll find that they've got so many things wrong. You know, for example, the idea that the sun is 93 million miles away, and you know, the angles and the degrees that you guys always quote, you know, is wrong, because you know, it could easily work on a closed sun and you know, the flat Earth. Let me give you an example. I mean, the first person to figure out, to calculate the distance to the sun was a guy called Encke from Germany in 1834. What he did was he sent out two of his associates to different parts of the world and to view the transit of Venus, right? And one location was impossible to view it because it was beyond the horizon. He wasn't able to view it, and they just made up the numbers, right? And he came to the conclusion that it was 97 million miles away. Then a few years later, somebody else came along and said, no, that's wrong. It's 95 million miles away. And then again, somebody else came along and said, no, hold on, guys. Let's make it 93 million miles away.
No, hold on.
Right?
Hold on.
And,
you're on track. You're on track. You're on track. Yeah, mic check's good. You're on track until you said, let's make it 93 million miles. See, what happens is people take careful measurements, they come up with a number, and then someone else finds out a way to refine the process, and they take better measurements, and they refine the number. And that is the process of practical scientific measurement. I mean, there's always an error, and that's what happened in that case. Notice that none of those guys ever said, oh, hey, you got it wrong. The sun is actually 3,000 miles away. None of them said that.
Well, and I was about to mention
deviation.
As time goes on, methods get more accurate. Of course, the number is going to change as your methodology increases in proficiency and accuracy. Change in science is not a bad thing. It's actually what we're trying to do.
Right.
No, it's not a change in science. What I'm saying is they got it wrong. The initial calculation was wrong.
Everybody that makes a measurement gets it wrong within a certain error. That is the nature of measurement.
It's a normal margin.
Yeah, what they tried to do was they tried to calculate it by using the transit of Venus, and one of the guys, the two guys that he sent out, this German guy called Encke, right? He sent two of his associates throughout the world, and they got it wrong. One guy, he wasn't able to view it. He wasn't able to see the transit of Venus, so they just made up the numbers, right? He just assumed it was 97 million miles away. There's absolutely no way that you can get a baseline, right, anywhere on the Earth to get that calculation to be accurate. It's impossible. Yeah, don't forget this was in 1834. They just guessed the distance.
I don't think that year is correct, but maybe it is. I don't know. I have to go back and look up the history on that. But the point is, the point is that if you try to locate the sun based on, or it's not just the sun, it's anything in the sky. Polaris is a good example. If you try to locate that based on the angle of your view of multiple people around the world, it just doesn't work on a flat surface. Polaris is really the best example for that. And so we know the altitude to Polaris is based on your latitude. I mean, that's just plain empirical science, observable. And if you then try and map that to a flat surface, it just doesn't work. Polaris would have to be in multiple different locations at the same time for that to work, which just doesn't occur.
Well,
so it just doesn't
actually,
make sense.
You have to go back to 1729 when Halley, Edmund Halley, he was the first one to suggest that you can measure the distance the distance to Mars, the planet Mars, all right, using the transit of Mercury, Venus, and he was wrong as well. He got it completely wrong. What he did, I don't know if you're aware, but what he did was he took a measurement. He thought he can get the baseline, right, from taking a measurement in the evening and then waiting 12 hours till the morning. He thought obviously that the Earth was spinning, is spinning around the sun. Obviously the Earth is stationary. Like, you have to first of all have to assume that it's spinning, but it's not. And he got it completely wrong. He assumed that the Earth will be certain miles away, yeah, and
No,
that's how they,
not yet.
That's how they got the distance.
You're just wrong about that.
To the planet Mars. It was false. It was a false presumption. He presumed that the Earth was spinning around the Earth.
Lewis has arrived. I'd like to
sorry.
welcome Lewis and give him the floor as soon as Multi's done.
It began with the faulty premise. If the foundation is wrong, the building's going to collapse. As simple as that.
Well, they haven't collapsed.
These guys, you have to research the Royal Society, which was set up in the UK, and it was the astronomical society. The Royal Society of Britain was primarily a philosophical. What would you call it? Research, and it was part of philosophy. Astronomy was part of the philosophical. Oh God!
So the thing about philosophy is that it isn't necessarily directly related to science, but it is like an intuitive guess as to where to look for science. And that's really where the philosophy of science comes into play. And
no.
Hold on, Multi. You've had time to talk. Now, Lewis Hackett showed up. I welcomed him, and I want to give him the floor because he was trying to respond to some of your points you're making. When you make a bunch of points in a row, it's too much to follow. Just make one point and let somebody else talk.
Yeah, you said they just assumed distances of Mars and Venus and the sun. That needs a citation, as far as I'm concerned. They didn't just make it up and soundly address that point already, and it's like you ignored him. They don't just make this stuff up. Hang on. They're going off of increasingly more accurate calculations as new information and new ideas come to light. And you should be aware that science never claims that what they're saying is absolutely true. They claim that it's the best explanation so far.
Yeah, I'd like to actually say something about that, and then I'll give it back to you, Lewis. Science is not deductive proof. So whenever people use the word proof, it can mean multiple things. It can mean deductive or inductive, basically. There's two broad categories that you can put it into. But deductive proof is the realm of mathematics. Mathematics deals with deductive proofs. But there are inductive proofs, and we use those inductive proofs to actually produce the physics, the knowledge of physics that we need in order to produce the technology that you're currently using to live stream, across the internet. Physics through inductive proof is what's responsible for the technology you're using. Back to you, Lewis.
All right. I mean, so to expand on that, it doesn't matter. Sure, everything we do follows a philosophical base when in any decision that we make, no matter where you're at, and what comes to determine who's got the best philosophy is, well, who can predict the future the best is basically how I would put it. If your mind can predict the future better than the other ones, and your philosophy predicts the future better than anyone else's, then yours can be said to be more true. And I'm using very broad terms here because no matter where I go on the flat earth here, people botch language, and it's really a butchery of the English language. So, you know, to try and put it in your own terms, it's so far below layman's terms. I think I made my point.
Yeah, well, I don't know if you guys ever researched the
We have. What do you think we've been talking about here?
What happened was your hero.
Who?
Isaac Newton.
Okay, not a hero.
Newton.
Not a hero.
Isaac
I don't know
Newton.
why you talk about him that way.
Right?
I said I don't know why you talk about these people in history who came up with these ideas as if they're heroes. We don't think about them as if they're heroes.
Well, you guys cite you know, you use his books as he was primarily you know,
It's not about him. It's about the ideas.
Right.
And I really don't think you understand any of it.
He was a philosopher. He wasn't a scientist. You know, if you
he didn't come up with calculus.
His book.
Yeah, he didn't develop integral calculus in the better part of an afternoon. Yeah, that wasn't.
His book was called Philosophy Mathematica Principia.
That was one of his books. That was one of his books.
Right.
You know, he made calculus, right?
That was not.
I'd like to hear your.
That was not a scientific book.
Who cares about
mathematical
philosophy? Philosophy and science are synergistic when it's used properly. Philosophy, whenever it's used properly, they're synergistic. It doesn't mean that they're proof. I mean, philosophical proofs are not proof of any type of science, but scientific proofs are. And he came up with scientific proofs in the inductive sense. He was able to measure and quantify what he saw in the real world. I mean, that's science.
What you guys don't know, is that astronomy was part of is a branch of philosophy. You know, from the time of.
I thought we just went over the fact that everything is essentially philosophy when you break it down, and what matters is what you can predict.
Yeah.
Well, philosophy is not fact.
So what can you predict, MultiT0mt0m?
Well, I can predict a lot of things. If you give me the data, from the the past 200 to 2,000 years, I can predict everything. You know, but
no,
what I'm saying is that is the astronomy is a branch of philosophy. Yeah.
So if you wanted to
if
you wanted to be able to put something up in the sky, how would you do it? That requires a great number of predictions, right?
The sky does not reflect the ground we walk on. The earth and the sky are two separate entities.
MultiT0mt0m, my point is there are numerous things, pieces of technology that can take a human and put them in the sky, whether it's a satellite, whether it's an airplane, whether it's a helicopter, whether it's a balloon. Right? So your understanding of the world is telling you that it's flat, right? And that conflicts with just about every law of physics that I know of, which those laws are responsible for the pieces of technology that can put people in the sky. So what can you tell me about the world that's so wrong? Why is my understanding of the world, which puts people in the sky, wrong?
Well, your understanding is flawed, first of all, because the sky.
In what way?
the sky and the earth that we walk upon are two different entities, right? All right.
No.
For argument's sake,
Let's say down, MultiT0mt0m. What is that force?
There is no force. There is no force.
Oh, really? So when I jump, I'm not pulled. I'm not forced back down.
No, there's that's because you're heavier than air. It's called density. Right?
So density means nothing. Density means nothing.
Hold on.
Okay.
Hold on. Let me interject that real quick.
Listen. Let's just say, for argument's sake, let's say that the sun and the moon. Let's say that the luminaries are all spheres, right?
No, you're jumping way too far ahead. We're talking about the physics.
This is why people get muted, Multi. And you can't just
what makes the Earth a sphere? If the sun, the moon, and the stars are all spheres, what makes?
I'm giving him some rope. Oh, Lewis muted him. Multi, let other people talk, dude. I mean, it's just real simple, polite. Anyway, it doesn't matter. There is a force that's not debatable. Something prevents us from pushing off the surface and continuing. Something pulls us back down, and whatever you want to call that is up to you. But at some point, somebody said, hey, look, there's this force, there's this behavior that we notice in reality where when you jump, you come back down. Let's give it a name. Okay, we'll call it gravity. And that's really all we're talking. I mean, whenever people say there's no such thing as gravity, they're basically denying the fact that they can't leave the surface of the earth by simply jumping.
So
I just like to point out. Sorry, I just like to point out without a force, there is no down. You do understand that, don't you?
Of course, there is. There is an up and down.
No.
Up
the only
is the sky. Down is the ground. What is so difficult to understand? You are heavier than the air.
Sure. The only reason there is a down is because there is a force pulling us down or pushing us down.
No.
Yes.
No. It's just
so
simple.
Is it density and buoyancy when a magnet visibly pulls on other ferromagnetic materials? Is that density and buoyancy too?
Your child can understand it. Like
I am talking so a child can understand it, MultiT0mt0m. Look, if a magnet is it density, right? MultiT0mt0m, is it density when a magnet pushes and pulls on things?
Heavier than the air. That it's simple.
Is a magnet changing the density of things when it attracts and repels other magnets?
Well, magnets don't come into the equation.
Yes, they do. Just like gravity, and your explanation of gravity being density and buoyancy is completely useless when you're analyzing it in terms of forces.
Let me tie these two concepts together real quick. When you have a magnet, which is noticeably heavier than air and denser than air, levitating above another magnet, why does that happen? Because there has to be something causing that. We call it a force. Right? Because obviously it's denser than air, so it should fall based on your rules. Why doesn't it?
Yeah, well, magnetism is completely different, isn't it? It's different than density. Density is just mass. If something is heavier than air, no. Of course, it's going to fall down. There is an up is.
What gives a mass
down?
Weight?
Listen. Up is up. It goes up. For example, smoke goes up to the sky. Yeah.
What?
Rain falls down because water droplet is heavier than air.
Why is
to
it
the
heavy?
Earth.
What gives a mass?
Magnetism is completely different.
What gives what gives mass
You don't
the
understand.
ability to be heavy?
Oh my God!
All right, Multi. Imagine
children.
imagine you're on an ice skating rink,
Are you children?
and you've got a big. Hang
Weight.
on, Multi. Relax.
It's simple.
Relax.
Simple logic.
Mass and weight are not the same thing.
Mass does not equal weight.
Multi, relax. Imagine you're on an ice skating rink, something that's as close to frictionless environment here on Earth as we can get, and you've got a bus sitting on that, and you're wearing ice skates. You can push that bus. It's not easy, but you can do it, and you can get it moving. And by isolating where the friction is into the plane perpendicular to up and down, you get rid of that, right? And you aren't changing density and buoyancy. You're applying a force to it. So are you postulating that there just is an infinite upness and an infinite downness with no explanation?
Oh my God! Do you guys understand? Right?
Yes, we do understand.
Mass. Do you understand mass?
Trying to help
Mass,
you.
heavy.
Yeah, we do understand. In an environment where it's frictionless, like I just gave, it's still difficult to push a large object because it has mass.
Are
mass, it has inertia.
Are rockets heavier than air, Multi? Rockets are heavier than
pen,
air.
right? Why does a pen drop when you drop it? You hold it in the air. When you drop it, it falls down to the ground.
Why do we have to exert
heavier than the force?
MultiT0mt0m, why do we have to exert a force to fly? Whether it's in a rocket, a helicopter, or in an airplane, why do we have to exert a force?
Because you need to be lighter than the air.
Right, so there's a force going down.
And you have to go up or you have to go down. And you're down to the ground because you're heavier than the air around you.
What gives you your weight? What makes you heavier?
Flap of her teeth.
That's mass. Mass makes you heavier.
All right. So gravity is
than the air.
Gravity is the simple concept that mass attracts mass, right?
No, it doesn't.
What's the most massive object in our existence? It's the Earth.
Yes, I agree.
All right. So what's the problem?
Yes. Yes.
What's the problem?
The sun is the problem. It's not heavier. It's not heavier than the Earth, is it? The sun is just light. It's a point of light, right?
So the Earth is. You think the Earth is heavier than us? Is that what you think?
Of course it is. That's why we're down.
Okay, so why
held down to the ground?
My question is, no, wait, hold on. If the ground is heavier than me, then it should fall the same way I fall because I'm heavier than air. Why isn't the ground falling?
Because the ground is bigger than you. You know, the ground holds you down. You know, you can't fall any further, can you?
But the ground can fall further. That's the point.